To the convex lens, draw a line representing the principal axis. Again, we need to mark the points optical center O and f1, 2f1 and f2 and 2f2. All these points are at the same distance from each other. In this diagram, the distance is 2 centimeters. Note that in a concave lens, usually the f1 and f2 are on the opposite side compared to a convex lens. So f1 and 2f1 are on the right side and f2 and 2f2 are on the left side. You might find different conventions in different textbooks. Now let's draw the concave lens. You can roughly sketch the lens or use a compass to draw the two arcs of the concave lens. Make sure the lens is thin. Don't draw a thick lens. Rule 1. A ray of light which is parallel to the principal axis after refraction appears to be coming from the focus. Rule 2. A ray of light going through the optical center of a concave lens goes straight through without being deviated. Rule 3. A ray of light going towards the focus after refraction becomes parallel to the principal axis. Let's place the three rules that we have learnt for concave lens on our concept board. Similar to the convex lens, can you see that rule 3 is exactly the opposite of rule 1? It's due to reversibility of light. You need to select 2 out of the 3 rules. Here I am on the principal axis at a certain distance from the concave lens. Again, we need to take the light rays from the top of the object. So from my head. Remember, we need to use 2 out of the 3 rules. For the first ray, let's use rule 1. The ray that is parallel to the principal axis after refraction, if we extend the refracted ray backwards, it appears to come from the focus. For the second ray, let's use rule 2. The ray going towards the optical center goes straight through without being deviated. Now, where do these 2 refracted rays meet? Since they are divergent rays, we need to produce them backwards. And the point where they meet is the image of my head, because we took the rays from the top of the object. So where are the feet of my image? We don't need to draw rays for that. You simply extend the image, that is the top of the image, to the principal axis and you get the bottom of the image. So as you can see, the image is formed between me, the object, and the concave lens. What are the properties of the image here? That's right, the image is virtual and it's upright. The image is diminished and it's formed between the object and the lens. Now let me walk closer to the lens. If you draw the ray diagram, can you see that we get the image having the similar properties? The image is virtual and upright. The image is diminished and it's formed between the object and the lens. In fact, the concave lens is the easy one in the syllabus because no matter where the object is placed, the image properties will always be the same. But remember, the convex lens had many different cases based on the location of the object.